ground fault circuit interrupter, or GFCI, can indeed replace an old receptacle in a bathroom, even if there's no ground wire present. The main purpose of a GFCI is to protect against electrical shocks. It achieves this by quickly cutting off power when it detects a ground fault, which is when electricity unintentionally strays from its intended path, perhaps due to damaged wiring in an appliance, and begins to flow through a person's body. When replacing an old receptacle without a ground wire with a GFCI, firstly, you must turn off the power to the relevant circuit. Locate the correct circuit breaker or fuse in your electrical panel and switch it off, or remove the fuse. This is the most important step to ensure your safety. Secondly, remove the existing faceplate and any screws that are holding the old receptacle in place. These are typically found at the top and bottom of the receptacle. Thirdly, carefully pull the old receptacle out of the electrical box. Be gentle to avoid damaging any of the existing wiring. Fourthly, take note of the wiring connections to the old receptacle. Typically, the hot wire is black or sometimes red, the neutral wire is white, and the ground wire, if present, will be green or bare copper. It is crucial to identify these wires correctly. Fifthly, disconnect the wires from the old receptacle. You may need to use a screwdriver to loosen the screws holding the wires in place. Sixthly, connect the wires to the new GFCI receptacle. Connect the hot wire, which is usually black or red, to the brass terminal on the GFCI. Connect the neutral wire, which is white, to the silver terminal on the GFCI. If a ground wire is present, it should be connected to the green terminal. If there is no ground wire, you will need to connect a pigtail of green or bare copper wire to the green terminal on the GFCI. The other end of this pigtail should be connected to a metal electrical box or a grounding rod if available. This provides a path for the fault current to return to the source. Seventhly, carefully push the GFCI receptacle back into the electrical box, making sure that the wires are tucked neatly inside. Secure the GFCI to the box with screws. Eighthly, install the faceplate and turn the power back on at the circuit breaker or fuse box. It is extremely important to test the GFCI after installation to ensure it is functioning correctly. To do this, press the test button on the GFCI. When you press the test button, the GFCI should trip and cut off power to the receptacle. Then press the reset button to restore power. Ground fault circuit interrupters are designed to be installed in areas where there is a higher risk of electrical shock. These areas include bathrooms, kitchens, garages, and outdoor locations. It is generally recommended that ground fault circuit interrupter receptacles or breakers be used in any location where water is present. Ground fault circuit interrupters have a limited lifespan and should be replaced every 10 to 15 years, or sooner if they are not functioning properly. Regular testing can help you determine if a ground fault circuit interrupter needs to be replaced. If you are not comfortable performing electrical work, it is always best to hire a qualified electrician to replace the receptacle for you. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. When working with electricity, always turn off the power to the circuit you are working on. Use insulated tools and wear rubber gloves to protect yourself from electrical shock. It's also essential to understand the different types of wiring configurations you might encounter. In older homes, you may find ungrounded wiring, meaning there's no dedicated ground wire. In such cases, a GFCI can provide a significant level of protection, but it's crucial to label the receptacle as no equipment ground. This informs future users that the receptacle doesn't have a direct path to ground. If your home has metal electrical boxes and metal conduit, bonding the GFCI to the metal box can provide a degree of grounding. However, this is not a substitute for a dedicated ground wire. Always consult with a qualified electrician to determine the best course of action for your specific situation. When connecting wires to the GFCI, ensure that the connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to a fire. Use wire connectors, such as wire nuts, to join wires together, and make sure the connectors are properly sized for the gauge of the wire. Over-tightening the screws in the GFCI can damage the device. Tighten the screws just enough to secure the wires, but not so much that you strip the threads. After completing the installation, test the GFCI periodically to ensure it's still working properly. Most ground fault circuit interrupters have a test button that you can press to simulate a ground fault. If the GFCI doesn't trip when you press the test button, it may need to be replaced. Building codes often require the use of ground fault circuit interrupters in specific locations. Check your local building codes to ensure that you're complying with all applicable regulations. It is also important to consider the amperage rating of the GFCI. Make sure the GFCI is rated for the same amperage as the circuit it's protecting. Using a GFCI with a lower amperage rating can overload the circuit and cause the GFCI to trip. When installing a ground fault circuit interrupter, follow the manufacturer's instructions carefully. The instructions will provide specific details about how to install the GFCI and test it. Consider upgrading other electrical components in your bathroom to improve safety. This could include installing a ground fault circuit interrupter circuit breaker, replacing old wiring, or adding additional outlets. When working with electrical wiring, it's always a good idea to have a helper present. This way, if something goes wrong, someone can call for help or provide assistance. Before beginning any electrical work, take the time to plan out the project carefully. This will help you avoid mistakes and ensure that the job is done safely and correctly. Firstly, ensure the ground fault circuit interrupter is Underwriters Laboratories listed. Secondly, verify the voltage rating of the GFCI matches the circuit voltage, typically 120 volts in residential applications. Thirdly, check that the amperage rating of the ground fault circuit interrupter matches the branch circuit breaker, often 15 amps or 20 amps. Fourthly, confirm that the GFCI is suitable for the installation environment, such as damp or wet locations. Fifthly, examine the wiring for any signs of damage, such as frayed insulation or corrosion. Sixthly, use appropriately sized wire connectors for all connections. Seventhly, ensure the electrical box is securely mounted and in good condition. Eighthly, follow all local electrical codes and regulations. Ninthly, after installation, label the GFCI receptacle as GFCI protected and no equipment ground if no grounding conductor is present. Lastly, keep a record of the installation, including the date, location, and type of ground fault circuit interrupter installed. Ground fault circuit interrupters are designed to protect people from electrical shock. They do this by monitoring the current flowing in a circuit and quickly interrupting the power if a ground fault is detected. A ground fault occurs when electricity flows through an unintended path, such as through a person's body. When a ground fault occurs, the ground fault circuit interrupter trips, cutting off power to the circuit and preventing electrical shock. Ground fault circuit interrupters are very effective at preventing electrical shock, but they are not foolproof. It is still important to take precautions when working with electricity. This includes turning off the power to the circuit you are working on, using insulated tools, and wearing rubber gloves. Ground fault circuit interrupters are required by electrical codes in many locations. Check your local electrical codes to see if ground fault circuit interrupters are required in your area. Ground fault circuit interrupters are an important safety device that can help protect people from electrical shock. If you have any questions about ground fault circuit interrupters, consult with a qualified electrician. The National Electrical Code, or NEC, provides guidelines for the installation of ground fault circuit interrupters. Refer to NEC Section 210.8 for specific requirements regarding ground fault circuit interrupter protection in dwelling units. NEC Section 406.4 D3 covers replacement of receptacles. When replacing a receptacle on an ungrounded circuit, a GFCI receptacle is permitted as a replacement if it is marked no equipment ground. The marking is essential to inform users about the absence of a grounding connection. The NEC requires ground fault circuit interrupter protection for receptacles located in bathrooms, kitchens, garages, and outdoor locations. The specific requirements vary depending on the location and application. Always consult the latest edition of the NEC for the most up-to-date information. Ground fault circuit interrupters are available in two main types: receptacles and circuit breakers. Ground fault circuit interrupter receptacles are installed in place of standard receptacles and provide ground fault circuit interrupter protection at their location. Ground fault circuit interrupter circuit breakers are installed in the electrical panel and provide ground fault circuit interrupter protection for the entire circuit. The choice between a ground fault circuit interrupter receptacle and a ground fault circuit interrupter circuit breaker depends on the specific application and the desired level of protection. When installing a ground fault circuit interrupter receptacle, it's important to understand the difference between the line and load terminals. The line terminals are where the incoming power from the circuit breaker is connected. The load terminals are where the wiring to other receptacles or devices on the circuit is connected. If the wiring is connected incorrectly, the ground fault circuit interrupter will not function properly. A common mistake is to connect the line wires to the load terminals. This will cause other receptacles downstream from the GFCI to also have GFCI protection. Some ground fault circuit interrupters have indicator lights that show the status of the device. These lights can be helpful in troubleshooting problems. For example, some ground fault circuit interrupters have a light that indicates when the device has tripped. It is not advisable to use an adapter that converts a 2-prong outlet into a 3-prong outlet without properly grounding it. It does not provide a safe ground connection. In older homes, it's common to find 2-wire electrical systems without a dedicated ground wire. Replacing receptacles in these systems with ground fault circuit interrupters is a good way to improve safety, but it's important to understand the limitations. Ground fault circuit interrupters protect against ground faults, but they don't protect against overloads or short circuits. Use the test button regularly, like once a month, to verify proper functionality.